All right, Michael. So I think that brings us to the end of what I wanted to talk about anyway. So can you help me remember what it is that we've learned today? In particular, what you've learned today.
Sure. So I guess the first thing I learned is that game theory can make you depressed. And in fact, in particular, that my friend Charles, given the opportunity, would totally drop a dime on me just to save a month of incarceration.
Yeah.
Wait, no. I don't think you summarized that correctly. Game theory is not depressed, it's depressing.
Oh, yeah, that's a good point. That's a good point.
And Michael is not cruel, he is the victim of cruelty.
I don't think so. Because you want to know what the secret here, Michael, is? You've got a little matrix of numbers. Those numbers capture what's going on. The truth, Michael, is that if we were in prisoner's dilemma, I would cooperate with you because my utility is not simply the number of months that I would spend in jail, but it's the number of months you also would spend in jail.
Ooh, interesting.
So if the best way to beat a prisoner's dilemma is to change the numbers.
I see. It's like the Kobayashi Maru of game theory.
Exactly. So there's an interesting question for you right there, Michael. If I had prisoner's dilemma here, let's write it out so you can remember. If I had prisoner's dilemma here, we already know that we're going to end up here because that's what the numbers tell us to do. But what we'd have to do is change the game. So how would you change the game in prisoner's dilemma?
I see. So if we're thinking about it in particular in terms of I care about how long you spend in jail, maybe not as much as I care about how much I spend in jail, like maybe half as much,
Mm-hmm.
then the payments shift, right?
Right.
So now we have like minus 1.5 in the upper left-hand corner,
Mm-hmm.
minus 9, comma, minus 4.5, minus 4.5, minus 9, and minus 9, minus 9.
So
So
yeah,
now that bottom right becomes a lot less attractive if we actually care about the other person.
right.
Oh, that's okay. I'm less depressed now.
Except, of course, that requires that you feel that way internally and that I feel that way internally. There's another way that you could change the game here, which is what happens to snitches in jail?
They are rewarded.
No, no, they're not.
They're punished.
Yes.
Oh,
So if you're a part of the criminal fraternity and you don't like prisoner's dilemma, then what you have to do is you have to create a system where the people who snitch get punished. So it's not just the months that they spend in jail, it's everything else that's going to happen to them if they drop a dime.
so you're saying that minus six ends up being worse?
No, when I
No, the minus. Wait, no, wait. What? Yeah. Oh, the zero ends up getting. Oh, I see. The zero ends up being worse because even though you're not in jail, you're going to get. I don't know, somehow thwarted or punished for your past behaviors.
accosted. That's right.
Interesting.
So that's what you have to do. And that works not just with criminals, but with the real world. Whenever you're in this sort of situation like a prisoner's dilemma, you can change the game by changing everyone's utilities. By, for example, hiring police officers, or hiring members of the mob to take care of everything.
I see. So it almost seems like what you're talking about is a kind of inverse game theory, where
Hmm.
if there's a particular behavior that I want to see, how do I set up the payments and rewards so that that behavior is encouraged?
Right. And by the way, that has a name, and it's called mechanism design.
Mechanism design?
Yes.
I'm not sure I understand either of those words.
Well, that's where you're trying to set up the set of incentives, the mechanisms that you're using to pay people. You're trying to design them in such a way to get particular behavior. This is what a lot of economics is all about. This is what a lot of government is about. Tax breaks, for example, for mortgage interest, encourages you to buy a home rather than rent a home.
I see, by changing the payoff structure.
Right.
Oh, that's neat.
Yeah. And so that's what we learned today, at least right now.
Okay. All right. So let's see. So just to try to rattle off some of the other things, the whole notion of game theory we talked about, especially the idea that you can think about a game as a tree or you could represent it as a matrix. And I believe you said repeatedly the matrix has everything. Is that how you said it? Or the matrix is all you need.
Yep.
Let's see. We talked about minimax and maximin.
Mm-hmm.
We relaxed a bunch of constraints on games.
Mm-hmm.
So we looked at both perfect and hidden information.
Mm-hmm.
We looked at both zero sum and non-zero sum.
And we learned a lot today.
We looked at deterministic and stochastic, I would want to say, but you called it non-deterministic. And assuming that we can get rid of the first two bullet items that look like maybe they were jokes,
Mm-hmm.
I would suggest saying things like we talked about what strategies are. and that they come in different flavors. We talked about the evil Prisoner's Dilemma game.
Mm-hmm. What else? You got to give me more, otherwise it's staying.
Oh, Moore. Good point. Andrew Moore gave lots of really good examples.
Yes.
Make this
Michael
lecture
may
happen.
be cruel, but Andrew Moore is awesome.
He's more cool than me.
Andrew Moore is very cool. All of the examples that we've used today, or almost all of the examples we used today, actually come from Andrew Moore's slides. Andrew Moore is a professor at Carnegie Mellon, or at least he was before he went off to Google, and is a really smart guy who cares very much about machine learning and game theory, and produced a bunch of slides that it turns out lots and lots of people use in their own courses. And his examples were so good for game theory that I decided to co-opt them with his permission, of course. He tells everyone that they may use them. And in fact, we have pointers to his slides in the resources links and folders for all of you to look at, and I recommend that you do. Did we learn anything else, Michael?
The only other thing that I would want to mention is Nash, which is a concept that is Nash-tastic.
It is Nash-tastic. There are, by the way, I should mention briefly, other kinds of equilibria concepts. They're beyond the scope of this class, but there's a whole lot more to game theory, as you might imagine. And sometimes when Nash gets you in these situations where you can't do what you want to do, you end up in these prisoner's dilemma situations, other kinds of equilibria can get you out of it. And I'm going to argue, without explaining why, that the way they get around it is by introducing other ways of doing various kinds of communication. And in fact, I claim they're a particular part of mechanism design. But that's a topic for another day.
Okay, fair enough.
Okay, did we learn anything else, Michael?
I don't know. That's what I was thinking about. I mean, that seems like a lot to absorb. And the other thing is that repeated games, even the Prisoner's Dilemma, kind of unravel if you know when they end. And I was going to try to look into what happens if you don't know when they're going to end.
Okay, so I guess that will be something that we will learn next time.
Right. What will we have learned?
Yes. Future past tense. All right, Michael, well, I think that's about it. At least my brain is full. So I will talk to you next time, and you get to lead what I believe is the last full lesson of the course.
Oh, exciting.
It is exciting. All right, well, bye, Michael. You have fun. I'll see you next time.
All right. Bye, Charles.
Bye.